Hey everybody, it is your favorite YouTuber here coming at you with a video on limits. We're going to look at them graphically, but also algebraically, and we'll throw in some L'Hopital's rule as well. So let's jump right in. First graph we have right here, we've got three different discontinuities. And so we're going to look at the limits of all of these as we approach them. And remember, limits are just coordinate points. Right, it's an x coordinate we're approaching. We're going to give a y coordinate we approach as our answer here. So we're going to start to the left of 0, So 0 is right here. And so our graph that is to the left of that is going to be this portion right in here. Okay, that is just to the left of 0. Now, as we get closer to 0, on the left over here, as we get closer to 0, the y coordinates get closer to the hole at 2. And so because the y coordinate here is getting really close to 2, we put 2. Again, it doesn't matter if there's a hole there. We're getting close to that point. And so our answer is just 2. Again, this is a coordinate point at, or a hole really, at 0, 2. Now, to the right of 0 means we're over here. We're just to the right of 0. Okay, so as we get closer to 0, we get closer to that actual coordinate point at 0, -1. And so our answer here is just going to be -1. And again, it doesn't matter if that point was filled in or not. We're approaching -1. We're getting close to the coordinate point at 0, -1. Now, as we approach 0 from both sides, because these values were different, right here we're approaching two different values, the limit from both sides does not exist. Does not exist. Again, it doesn't matter what happens when x is 0. It matters what happens when we're close to 0. And so as we're close to 0 here, they're approaching different values, therefore the limit doesn't exist. Now, what is that actual coordinate point good for? Well, that tells us f of 0. So when x is 0, and we're at the actual point, there's nothing here, there is a point here, so that is how we find f of 0. All right, let's look at -2 now. We're going to approach -2 from both sides. Okay, so -2 is right here. When we're just to the right of -2 or just to the left of -2, we're approaching the same y coordinate here. We're getting close to the y coordinate at 1, and so this is going to equal 1. F of -2 means when x is -2. Well, when x is -2, there's no points on this graph, and so f of -2 is undefined for this question. All right, up next as we approach 1. So 1 is right here. There's a point up here, but as we approach 1, that means we're to the left of 1, to the right of 1. Both of those values are approaching a y coordinate of -2. And so our answer here is -2. But when x is 1, the graph is up here. There's a point. And so f of 1 is going to equal 3. All right. Looking at another graph, we've got a vertical asymptote. We've also got a horizontal asymptote here. And so this first one is asking for the limit as x approaches -infinity. That means our graph is moving further to the left as x approaches -infinity. So as the graph goes further to the left, we're getting closer and closer and closer to that horizontal asymptote at -2. And so our answer here is going to be -2. Now we're moving towards positive infinity. That's going to mean to the right. So as the graph goes further and further and further to the right, we're also going to approach the horizontal asymptote at y equals -2. Now, this may be obvious based on this graph, but we have a horizontal asymptote at -2. And so the reason I want to mention this is because later I'm just going to ask for this right here with a different type of question. You're not going to be given a graph, but I'm going to ask you for the horizontal asymptote. And you have to know that what you're finding is this. Okay? Some graphs do have 2 horizontal asymptotes, most only have 1. We're going to focus in on the ones that only have 1, so you guys could find either. But again, technically a graph could have 2 different horizontal asymptotes as we go to the right or as we go to the left. All right, now as we approach -1, so that's where our vertical asymptote is. Okay? So when we're to the left of -1, that would be over here. Okay, so left of -1 is this part of our graph. Okay, we're going to get closer to the -1. And as we do that, our graph is going up. And so the y coordinate is going to approach infinity. To the right of -1, that would be over here. The graph is moving down as we get closer to -1. And so our y-coordinate's going to approach negative infinity. Now, as we approach from both sides, these two values are different, so automatically the limit does not exist. Does not exist. Okay, that would also be an acceptable answer for the previous two. We could put infinity or does not exist, negative infinity or does not exist. All right, now let's look at some of these without being given a graph. And so we've got 3 limit questions up top here. The first thing you should always do with the limit is try to plug in and see if you get an answer. Okay, so if I were to plug in 2, I do get 0 on the top, but I would also get 0 on the bottom. And so what that tells us is that the graph has a hole, has a removable discontinuity. And so this one is factorable. I could factor and cancel, and then I could plug in the 2 again, or you might remember L'Hopital's rule. I'm going to go ahead and use L'Hopital's rule. Whenever we get 0 over 0, we can use L'Hopital's rule. All right, so L'Hopital's rule says, without using the quotient rule, take a derivative of the top, take a derivative of the bottom, and now plug in that number again. And so if I plug in 2 to the top, I get 4. If I plug in 2 to the bottom, I get 4 minus 3, which is 1. And so we just get 4, and that's our answer here. All right, if I'd gotten 0 over 0 again, well, I would take another derivative of the top and another derivative of the bottom. Okay, but only if you get 0 over 0 can you take another derivative here. Okay, so that's the first one here. The second one, when we're approaching infinity, if I was to plug it in, yes, it's going to be a determinant, so I could use L'Hopital's rule, but we could also just, if they're both polynomials, okay, we could just take the highest order terms, the largest exponent from the top, the largest exponent from the bottom, and we can ignore everything else. And again, that's only if we're approaching positive or negative infinity can we do that here. Now, x squared over x cubed is going to simplify into 1 over x. We subtract the exponents, but the bigger exponent is on the bottom. Okay, 1 over x. Now, if I plug in infinity, I get a number over infinity. And any number, doesn't matter how big or small, any number divided by infinity is going to approach 0. And so that's our limit here. Okay, and really anytime the degree is larger in the denominator, if we're approaching infinity, it's going to equal 0. If it was flipped, okay, then it would approach, it'd be infinity over a number, that would be infinity. And if they were the same, it would be the fraction of the leading coefficients, and we'll look at one like that in just a second. Now, next question. I just want to remind you guys of something. So, say we have a negative infinity, and we plug it in for x. Okay, so we get e to the negative infinity. Okay, negative exponents we need to get rid of in order to actually evaluate what this is. The way we do that is we make a fraction. On top, we always put a 1. We put this whole thing in the bottom, but without the negative. E is a number. It's a decimal, or 2 point something. So this is decimal, and so this is 2 point something times itself forever. And so the bottom just becomes infinity, and 1 over infinity is again 0. All right, so that's our answer for that one. All right, so our last question here, find the horizontal asymptote of this, and then we're also going to look into the vertical asymptote and the removable discontinuity, or the whole. But the horizontal asymptote, this is the same question as asking for the limit as x approaches positive or negative infinity. Okay, so what we're going to do then is we're just going to take the highest order terms, that's these two. They have the largest exponents. And we're going to ignore everything else and just simplify. And so here we cancel out the x squareds, we would have a 1 on top, a 2 on the bottom. So our horizontal asymptote is just going to be y equals 1 over 2. All right, that's all we have to do for that one here. Now, for the vertical asymptotes and the removable discontinuities, you've got to put this in factored form. So if I factor the top, difference of squares, we get x plus 2, x minus 2. And if we factor the bottom, we get x times 2x plus 1. All right, so nothing cancels here. So there's no holes in the graph. Okay, no removable discontinuities. Vertical asymptotes come from when the denominator is equal to 0. And so I would just set both parts of the denominator equal to 0. That would give me x equals 0 and x equals negative 1/2. All right. These answers at the bottom count as discontinuities. this is not a discontinuity. So if the question asked us to find discontinuities, it's just these down here, not the horizontal asymptote, okay? A common mistake here is to set the numerator equal to 0. That would only give us the x-intercepts or the zeros of this graph. It would not give us any of this information right here. All right, so you guys should be good to do your practice now. I'll post one more video on limits and maybe another topic or two for you guys later this week. But that's it. Thanks for watching. And as always, stay flawless.